break. Sure, you guys are all extremely happy to be here. Compared to, doing whatever you were doing over break. Purdue game was fun last night.
Sure.
Yeah, that was good. Kind of interesting that they were able to hold off a team for almost 10 minutes. And then, they threw that away pretty quickly. But whatever. All right, so before we get too far into things, there are a couple announcements I just want to make real quick. The first one is, again, we are asking everyone to continue wearing masks in here and in 236 for the remainder of the semester. We're just calling it a professional courtesy at this point. Please be a good example and continue to do so as well. That is greatly appreciated. Thank you. The other thing, I figured we should just get this date out there now. I'll be making a post on Piazza relatively soon about it. Last semester, David Gormley hosted a seminar kind of describing the general layout of the final project and kind of giving advice for topography and everything else like that. And it went really well. So we're going to continue that this semester. I'm going to do it for 2 nights on April 18th and April 19th. It'll be in Electrical Engineering 170. It's a decent sized lecture hall, but technically it is not big enough to fit everyone at once. So we'll be doing the 2 nights just in case people would like to come. I am also more than inviting you guys to come. In fact, if you would be willing to, I would really encourage you guys to come along. Any insight you guys could provide as well would be great. It would be great to see you guys there showing your support for the students as well. And again, that is paid time. That is stuff that you would get paid to do. Yeah, those are the big ones. This week is timing. Kind of a fun lab. It's not overly complicated. The math isn't terrible, right? So a lot of that's already inside the 555 timer for you, so that's pretty nice. You're going to find this semester really focused on the practicality. Okay? A lot of our students are mechanical engineers or just generally outside of ECE. So this is arguably going to be one of the most productive labs and most, I guess, useful for them outside of this lab setting, because I cannot tell you the number of senior design questions I've helped with in mechanical engineering or otherwise that literally can be solved with a 555 timer and 3 lines of a microprocessor code, right? So if we can maintain that, and if we can really show the practicality for here, the 2 main circuits that they're doing in this lab are a doorbell and a strobe light, which ironically are pretty identical in circuit-wise. But, it doesn't take much to change that to, say, a PWM driver, right? So if you can try to make those connections and try to make sure your students see those connections, that would be great. Any questions for me? All right, that's about all I have. Thank you to everyone that's been helping me over break. We have quite a few projects going on right now. We have some people working on an error database. We have some people making a value checker so people can test values for their pre-lab and stuff like that. So that's kind of cool. We are working on formalizing more of the lab reports or lab setups that we tried in 29595. So we actually have a more, I guess, professional version we can try out next semester in the 295 sections and then push that out hopefully next spring. Those are the big ones. What else do we have going on? All sorts of fun stuff. Yeah. If anyone is interested in helping making pre-lab quizzes, Altair's been helping with that. We're going to just kind of, I'm hoping for less than 5 questions, one of which is a yes or no question stating that they have watched the videos. And, if they answer that, they get 20% of the pre-lab quiz. So if you guys want to help out with those, that'd be great. We're going to just do those rated Brightspace so they grade automatically. Let me know if that's something that interests you. Any questions for me generally right now, or any questions I can answer management-wise or anything like that? Please make sure you sign up for meetings if you haven't done so already. It's been great to talk to everyone that has come so far. I'm looking forward to the rest of you this week. It's a pretty full schedule, so it's exciting to see. So again, I really do, for those that have been to my office already, I really do appreciate those meetings. They mean a lot to me, and I learn a lot from them. So if you haven't signed up yet, I would really appreciate you signing up. That's about it. Fair enough to you.
Okay. So before talking about this week's lab, I think all the GTA you already received the email for the midterm grade review. So we will do it next week. So please, for all the UT and GTA, please try to finish all the grading until Lab 7. Okay, include Lab 7 write-ups and also Lab 7 pre-lab. And also the report of Lab 5 and the lab practical. I think there are still a couple sections didn't finish the report and probably the practical.
And please make sure you refresh your grade scope roster so that was a terrible word, sorry. Please refresh your grade scope roster so that the English TAs pop up there too, so they can grade it right.
Yeah, and also after you finish the grading, please publish on the Brightspace. Okay. So this week will be the RC and the RL step response circuit and also the timing 555 timer circuit. So make sure you tell the student watch the video before the lab. And actually in the pre-lab, they already built the RC circuit and they should already familiar with the circuit. And you can quickly go through this at the beginning of the lab. Like for the RC circuit, the voltage is increased, the current is decreased, and inversely for the RL circuit. But don't spend too much time on this. And also like the time constant, okay, like it take R times 6 seconds to charge until like 63% of Vin. Okay, so they should already done this in the pre-lab, but probably you can also mention this quickly at the beginning of the class. Right, and let's see, timing circuit. Okay, so the 555 timer, basically it's just there are two op-amp as a comparator as the input, or the threshold and the trigger part, and then connect with the SR latch, which is kind of like a digital circuit. So I think it's kind of it's not easy for the student to fully understand how this works. I think it kind of depends on you. You can quickly talk about this, like how the work theory of 5.5 timer, or just let them to watch the video before the class. I think basically you want to mention there are three modes of the 5.5 timer: the astable mode, monostable mode, and also the bistable mode. Okay, so and tell them what's the function of each mode. Right. So let's see. Task 1, they are going to repeat the circuit in the pre-lab. Instead of the capacitor, they are going to measure the time constant of the inductor. So yeah, so make sure they use the math mode on the scope. Let me use my PPT here. So right here, this plot right here is actually the plot they should get from the pre-lab. Okay, so this is the response of the voltage of the capacitor, and they use the cursor to measure the time constant of the RC circuit. And after for the task 1 of this week, they probably will get something like this. Okay, so some students may think they get the wrong plot, but actually if they zoom in, they will get the time constant plot, okay? And there are two ways they can measure this. One way they can measure the time constant from top to bottom, or they can use the mass function to use Vs minus Vl, so Vin minus the voltage cross inductor. They will get this red line here. That looks very similar with what they get from pre-lab. and they can use the cursor to measure the time constants. Okay. Just make sure when they take a screenshot, try to let them to include the cursor in the screenshot, and then you know they are doing it in the right way. Okay, and also tell them when they do the calculation, like tau equal to L divided by RTH. RTH is equal to the R sense, well, not R sense. It's the R sense plus RESR. RESR is the internal resistance of the inductor. Right. So yeah, I think that's task 1. And then task 2, they are going to build the circuit for with the 5/5 timer in a monostable mode. Basically, just like they push the switch, and the LED will turn on for 5 seconds, then it will turn off. So they will going to use this equation. Okay, so basically T equal to 1.1 times RC. The RC is the R1 and C1 in the circuit diagram, and the T should be 5 seconds. Okay, so they should get this equation from their pre-lab. Okay, I think that's question 2 in the pre-lab. Okay, one thing, there are couple common mistake for this task is first of all, make sure they know the pinout in the circuit diagram on the manual is different from the datasheet pinout. Okay, the datasheet pinout is the real pinout. Okay, so make sure they check the datasheet. Don't use the pinout on the manual. Manual is only the circuit diagram. And the second one is mentioned in the other PPT here. So when they build the LED here, make sure they have the series resistor, 313 ohm resistor with the LED, because the LED doesn't have any resistance. Okay, so if you directly connect it, you basically short the output. Okay, and also don't forget the coupling capacitor at the VDD and ground. Okay, let's see, back to this one. So after they did everything correctly, they should get this plot. Okay, I did this in the 82, but they will have a screenshot for the oscilloscope, and make sure when they take a screenshot, they use the row mode, and also like they will need to pause this screenshot and use the cursor to measure when it's turn on and turn off. The time will be 5 seconds. And if you check the step 3, or not, step 2, when they measure this with let's see, yeah, never mind, step 3, when they measure this with the oscilloscope, the oscilloscope have some internal resistance. Okay, so if they put like R1's value to be some larger value, like 1 mega ohm or even 500 k ohm resistance, that will cause some like loading issue when they measure with oscilloscope. It will work when they just test it, but the function will change when they plug into the oscilloscope probe. Like if their value is too large, probably the LED will never turn off. Okay, so make sure there are 2 ways to solve this problem. One way, you just tell the student the R1, they don't use like a very large value, probably smaller than 300K or 500K ohm. Or make sure they use the times 10 mode on the probe. Okay, that will make the impedance of the probe like 10 times larger, which will avoid the loading issue. I think that's task 2. Okay, and another thing for task 2 is the switch. Okay, so you see the switch on the schematic. There are two methods to build the switch. One way is the simple way. They just use the wire to plug in and plug out. That's like function as a switch. Or they can use the push button. Okay, so make sure they tell them like the push button is something looks like this. And push button, there are 4 pins. Okay, these 2 pins actually are already short together, and another 2 will short together. When you push it, these 2 will short together. So either you can tell the student or tell the student to use the continuity of the DMM to measure what's the like the pin or how the function of the switch. Okay, so then they know how to build the circuit with the switch. I think that's task 2. Then the task 3 should be similar with task 2. They will build the 5-5 timer with the stable mode. Okay, basically, they still use the value they get from their pre-lab, and they will measure the output and also the threshold voltage. Okay, the output will be like a square wave, and the threshold voltage will probably something like this. Okay, it's like charge to 2/3 of the VDD and discharge to 1/3 of VDD and charge again. Repeat the process. And also make sure that you tell the students when they take a screenshot, make sure they include the measurement for the duty cycle and the frequency. Okay. I think here is some common mistakes I found out from previous semester. The first one is I mentioned is for the pre-lab. Is the capacitor probably not fully charged if they didn't set the frequency correctly. And the second one is the one I mentioned. They thought their step response was wrong. It's like a straight line, but if they zoom in, they will get the actual step response. Until the third one, make sure you tell the students the pinout is different from the manual figure and the datasheet pinout. Okay, the datasheet, the pinout is the real pinout. Okay, the third one is the fourth one is a switch, and don't forget the LED series with resistor. And for the task 2, make sure the R1 not too large, or use the times 10 mode for the probe. I think that's all for this week. I think this week should be pretty straightforward. And I think it's kind of a fun lab for the 5-5 timer, 5-5-5 timer. Do Ben and Adam, do you have anything to add?
No, I don't have anything much to add. Yeah, again, fingers crossed, it should be fairly straightforward and go fairly quick. This one it can be very annoying working with the 5-5-5 timers sometimes because they can be really finicky, but once you get it set up and going, it's one that people typically have fun with because rather than just making a circuit and being like, oh, I made a circuit, it's like they actually get to do something with it. That's kind of fun. So it's a little bit more practical. And yeah, that's about all I have.
One big thing to note, if they do wire it the same way that's in the manual, i.e. they treat each pin just like pin 1, pin 2, pin 3 all the way down, it's gonna short, because the ground is in a different spot, and you're essentially gonna create a current sink through it, and it's gonna start smoking. Please make sure you encourage them to double check the data sheet. Definitely don't know that from experience.
Yeah, something like this. This is the real data sheet. I mean, real pinout. It's different from the one in the menu. So make sure you tell the students. Okay. I think that's all. I think
Any
that's
questions, concerns? If you guys are willing to take the time to actually, oh, one more thing, real quick. Lab 13, we're gonna go a little bit ahead of schedule right now. If you have spare time in the next week or two, I would like you to try something. In Lab 13, that's the rectifier lab. For the second circuit, where they connect using the transformer that we plug into the wall, that can create a lot of current if it's made incorrectly with the short circuit out. So when they're actually making the circuit themselves, last semester, I'm not sure what it was like previous semesters, but last semester, we had a lot of transformers die on us. So to avoid that, I have these rectifier chips. They're essentially just 4 pins. You have 2 going in, 2 going out. I want them to still make the rectifier for the first circuit, but we're going to drop the voltage so they can use it with the function generator. For the second one, we're going to use these rectifiers instead if it works out. So if you could please try it out. All the rectifiers are up here. If it works or it doesn't, more importantly, if it doesn't work, let me know. Send me an email or something. Try it out. Okay? I tried it. It made sense to me. It worked fine for me. But I would like you guys to try as well to make sure it's going okay. Does that kind of make sense? Okay. Thank you very much. They are labeled. You have your plus and minus on one side. That's your actual voltage coming out. And then the squiggly lines are your AC going in on the primary side. That's about it. Thank you for your time. Relatively quick one today. If you guys would like, use this time to actually go over the lab, try out the lab yourself. If you need 555s, we have plenty of them in the shop as well. So feel free to stop by and grab one yourself.